Welcome friends. In this video I am going to discuss about the experiment comparison of acid strength, iodination of acetone catalyzed by sulfuric acid. Varying the concentration of sulfuric acid will change the rate constant of the reaction. From the kinetic study of this reaction, we can compare the strength of sulfuric acid used in this reaction. Acetone is protonated by the sulfuric acid in the first step. The second step, protonated acetone is converted into enolic form, followed by loss of a proton. The enolic form then react with iodine and gives the product. This is the first step. Sulfuric acid donates proton to the acetone. Now the acetone is protonated. The protonated acetone is converted into enolic form. By the loss of proton. Now this enolic form is react with iodine and give the product. From the mechanism of this reaction, between acetone and iodine, it is revealed that the initial step is attack of proton with acetone and gives protonated acetone, and hence it is independent on the concentration of the iodine. So after deprotonation and converting into enolic form, then it is react with iodine, and hence the reaction is only depend on the concentration of the catalyst, but it is independent on the concentration of the iodine. This is the overall reaction taking place. Procedure of this experiment. It requires 2 bottles will contain acetone, about 10 ml of acetone, 50 ml of sulfuric acid and 30 ml of distilled water in one bottle. The other bottle contains almost 50 ml of 0.1 molar iodine in 10% potassium iodide solution. Both bottles were kept in a thermostat to attain thermal equilibrium. After attaining the thermal equilibrium, 10 ml of the iodine is poured out into the bottle containing acetone. Immediately 10 ml from this content is pipetted out into a clean conical flask which already contains 10 ml of sodium acetate of 1 normal. And further it is added by starch indicator. The solution will turns into deep blue color. This solution is titrated against thio, that is sodium thiosulfate of concentration 0.01 molar. 0.01 molar. End point is the change of deep blue color into white color. This is the end point. On end point we note the volume of thio. From the volume of thio we can calculate the initial concentration of iodine, which is I2 naught, initial concentration of iodine. After 3 minutes time interval, again 10 ml of this iodine mixture is taken in a conical flask. 10 ml of sodium acetate is added to arrest the reaction, followed by starch and titrated against thio. The end point is noted. At various time intervals, we can calculate the concentration of iodine at the various time intervals. From these two concentration, we can calculate the rate constant of this reaction. So this is the trial 1. This is the trial 1. We have to do 2 more trials by employing same procedure, but the concentration of the catalyst, sulfuric acid, is different. In the trial 1, the sulfuric acid, 50 ml of sulfuric acid is of 0.1 normal concentration. The same procedure is repeated in the trial 2 and the trial 3. So in the trial 2, we have to use the concentration of sulfuric acid. We are using the sulfuric acid of concentration 0.15 N. And in the trial 3, we are using the sulfuric acid of concentration 0.2 N. At varying the concentration of the catalyst, there will be a change in the rate constant. At varying the concentration of acid, we can compare the strength of acid from the rate constant of this reaction. Endpoint of thio for the reaction in which 0.1 N concentration of sulfuric acid is used as a catalyst. At the time 0, endpoint of thio is 18.5. From this endpoint, we can calculate the concentration of iodine. That is I2, initial concentration 0, 18.5, this is volume of thio, into 0.01 concentration of thio divided by 2 into 10. If we multiply and divide by 2 into 10, we will get the value of 0.00925, and we can simplify that value into 9.25 into 10 power minus 3. So 9.25 into 10 power minus 3 is the concentration, initial concentration of iodine. So that we can calculate the concentration of iodine at various time intervals using the same formula. I2 at various time intervals, 16.9 into 0.01 divided by 2 into 10. So we'll get the value, and we have to simplify the value. Based on this calculation, we have obtained the values of concentration of iodine as 8.45 into 10 power minus 3. That is, we get 0.00845. We have simplified and 8.45 into 10 power minus 3. And for 15.1 we get the value 7.55 into 10 power minus 3. For 13.8 we get the value of 6.9 into 10 power minus 3, and for 12.7 we get the value of 6.35 into 10 power minus 3, and for 11.4 and 10.2 5.7 into 10 power minus 3, and for this 5.1 into 10 power minus 3. This is the value from at various time intervals, the value of concentration of iodine. This is the initial concentration, rest others are concentration at a varying time. From the concentration of iodine, that is from initial concentration of iodine and the concentration of iodine at various time intervals with respect to time, we can calculate the rate constant of the reaction, rate constant of this reaction. Okay, so what is from the value of concentration of iodine, initial concentration of iodine and concentration of iodine at different time intervals with varying time, we can calculate the rate constant of the reaction using the formula K is equal to I2 naught minus I2 T, concentration of iodine at the initial minus concentration of iodine at the various time interval divided by dt at the varying time. So K is equal to the initial time, so there is no time difference, we could not calculate for this volume of thio 18.5. For the time interval of 3 minutes, we can calculate 9.25 into 10 power minus 3 minus concentration of iodine at 3 minutes, 8.45 into 10 power minus 3 divided by dt is 3 minute, we will get the value of 0.000266. We can simplify this value into 0.266 into 10 power minus 3. This is the rate constant at 3 minutes time. 0.266 into 10 power minus 3. After 6 minutes, we can calculate K is equal to 9.25 into 10 power minus 3 minus 7.55 into 10 power minus 3 divided by dt is 6 minutes. So we will put 6 and we get the value of 0.000283. We can simplify this value into 0.283 into 10 power minus 3. So after 6 minutes of time, the time is after 6 minutes of time, 283 into 10 power minus 3 is the rate constant. Using this formula, we can calculate the rate constant at every interval. For time taken is 9 minutes, the rate constant is 0.261 into 10 power minus 3. 0.261 into 10 power minus 3. After 12 minutes, we have calculated 0.241 into 10 power minus 3 using the same formula. After 15 minutes, it is 0.236 into 10 power minus 3. After 18 minutes of time, it is we have calculated using the same formula 0.230 into 10 power minus 3. From the values of rate constant, we obtained an average K is equal to 0.2529 into 10 power minus 3 mole per decimeter cube per mole per decimeter cube per minute. This is the unit of the rate constant. At varying the concentration of sulfuric acid, 0.15, we may get at various time intervals volume of thio. We can convert the volume of thio into, we can calculate the concentration of iodine, and then we will get the rate constant for that particular concentration of catalyst, and also we will get the rate constant of rest one another catalyst concentration, different concentration 0.2. Taking the value of concentration of iodine in the y-axis and time units in the x-axis, we can plot a graph. So for this x-axis and the y-axis, we'll get a line. We'll get a line and a slope. We'll get a line and a slope. From the slope dy by dx, we can calculate the rate constant graphically. We can get the rate constant graphically. Ratio of the rate constant obtained by calculation and by the graphical method gives the value of, that is the strength of acid, so that we can compare the strength of acid from these ratios. So further we have to calculate the rate constant for 0.15 concentration and also 0.2 concentration. We'll get the rate constant for both the two concentration like this. That two rate constant can be plotted in a graph. We can also calculate the rate constant of that two concentration by graphical method, and hence from the ratio of rate constant we can compare the strength of the acid. When we plotted these two values, concentration of iodine and the time, we get the dy by dx value of 1.4 divided by 7. From the slope we will get 0.2. So rate constant from the graphical method is K is equal to 0.20 mole per decimeter cube. Rate constant of the reaction in which 0.15 normal sulfuric acid is used as a catalyst. This is the rate constant of the reaction, that is the trial 3, in which 0.2 normal sulfuric acid is used as a catalyst. Rate constant of the reaction in which 0.1 normal sulfuric acid is used as catalyst is given in the first set. The catalyst in which is employed in the second trial, that is 0.015, is mentioned in the second set, and the acid catalyst of concentration 0.2 used in the reaction. For that reaction the rate constant is given in the third set. 3 graphs were plotted using the value of concentration of iodine and time. From the graphical method, rate constant has been calculated. From the rate constant, ratio of the strength of the acid is noted. So the ratio of strength of the acid obtained from graphical method is 1:0.97:0.83. If you have any queries regarding this experiment, you can post your queries on the comment box. Thank you very much for your patient listening. Thank you.